Yo, what's going on, guys? What's happening? So, this video title is perfect, I believe. I believe it's perfect because I'm about to go into why I think it is perfect. So, the first thing we do, of course, when we're solving any circuit, right, is we label our points, right? So, we already got our essential nodes out, right? Because LT Spice does that for us automatically. So, we already have our essential nodes, right? So, let's start labeling points that we know, right? So, okay, we know our ground is 0 volts automatically, right? Our ground is automatically 0 volts, right? So let's look at this, right? So if we have 0 volts on the ground, right, that means, and there's a resistor here, right? And we know resistors, right? They go from low potential to high potential, right? Or that's how electricity travels. It's not necessarily a resistor, it's just how the electricity travels, right? So if we know that for a fact, right, and we know this is 0 volts, that means this has to be a negative voltage, right? Because for there to be a voltage difference across this resistor, and this to equal 0 volts, there has to be like a negative voltage here. Same thing with our positive, like, yeah, same thing with our positive here, right? Look at, like, as you can see, the batteries are, their orientations are flipped, right? This is negative to positive, but this is positive to negative, right? And the positive terminal, as you can see, is connected to ground, which is 0 volts. So if we want this to be 0 volts, right? I mean, if the positive is negative, I mean 0 volts, that means the negative is now 12 volts, right? So we have 12 volts on the negative, which shouldn't be happening, right? And basically, what that means is, well, I don't know for sure. So we're gonna figure that out. We're actually gonna learn that together. But as you can see, there's still a 12 volts difference across this battery. But yeah, so now we have a negative terminal with 12 volts, right? So we'll figure all that out later. So we don't necessarily know the voltage right here. Actually, yeah, we do. It's 12 volts. It has to be 12 volts anyway. So let's label it 12 volts. It could be negative 12 volts, but I genuinely don't know for certain. But I know it's 12 volts for a fact. So I know that for at least a fact. It's at least 12 volts. It could be negative 12 volts, but like I said, we're going to learn it together. So, and as we can see over here, this side is also going to be 20 volts, right? So this is 20 volts, right? Oh, I forgot to put the V. Oh, well. So we labeled all the points that we know. And let's do our label our VA. Here we go. Our essential node. All right, boom. There you go. All right. So now what do we want to do now? So let's see what we can do now, right? Let us see what we can do now. What I want to do now is I want to write Ohm's law. I want to write Ohm's law. So let me do that real quick. I times R. Oops. Oh, no. That's not good. Well, let me go ahead and fix that. All right, so we got I times R. Here we go. And here we go. I also want to write our voltage difference equation. So let's do that. VD equals high potential minus low potential. Let's remember that also. And we are going to do what? VD minus. So we did that. Now what do I want to do? I don't know what I want to do. What do I want to do? Oh yeah, I want to do VD, VDR divided by RW equals IW. So the voltage difference across the resistor divided by the resistance of that wire is going to equal the current of that wire. Okay, here we go. So we wrote out all our equations now. So all our equations are on deck. Let me see if I can move it to the corner of the screen just to have some more room. All right, here we go. There you go. All right. So what do I want to do now? What do I want to do now? All right. So yeah. So we know this point has to be negative, right? Because it doesn't make any other sense otherwise. Because or else it wouldn't be able to. It would not be able to travel. It literally would not be able to travel to the positive terminal of the battery if it was not negative. So don't worry too much about that. I'm just trying to tell you guys beforehand but we're going to see. All right, so let's start labeling our equations now. So theoretically, we're going to have the current go this way, even though, like I said, we know the current travels this way, right? We know that for a fact. That's what's happening in reality. But for the sake of theory and solving this equation, this circuit, we're going to pretend that the electricity is going this way, right? To the high potential of VA, right? So let us do that. So in order for that, we got to switch these signs. So let's switch the signs real quick. We're going to have, and this is the low potential. All right. So we're going from the low potential of ground, which is 0 volts, right, to this high potential, whatever this is going to be. We don't know what it is, but whatever that's going to be, right? Hold on. Hold on, guys. I'll be right back. All right. So as I was saying, we're going to go from the low potential of ground to the high potential of whatever this is, right? Then we're going to go to the battery. We're going to get a voltage lift. And actually, I lied. We don't know the value of this because of that resistor right there. If that resistor wasn't there, we would know the value of it. But since that resistor's there and there's a voltage difference here and we don't know it, so we don't know what we're gaining or whatever. So we're going to go through here, right? And we're going to hit this resistor. And this is where Ohm's law is going to take effect, which is also where our equation right here is going to take effect, right? So let's do that. Let us do that. So, since we don't know the current across this stuff, but one thing we do know, all right, in a series circuit, right, when a battery is complete in a circuit, correct, it has to be through a difference of 20 volts. Now, it doesn't matter. The negative terminal could be 5 and the positive terminal, so let's label that. Negative terminal could be, well, actually, I don't want to put negative. But negative terminal could be 5, and I'll put NT for negative terminal. Negative terminal, the negative terminal could be 5, right? NT equals 5. Oops, I didn't mean to write that out. Oh well. So the negative terminal could be 5, and the positive terminal could be equal 25, right? Now, those values don't matter. There's still a voltage difference of 20, right? It doesn't matter what those values are. There's still a voltage difference of 20, right? Because 20, the high potential, the positive terminal of 25 minus 5 is going to be 20 volts, right? So it doesn't matter. So what we're going to do, again, we're going to do the voltage difference, right? We're going to do the voltage difference minus VA, right? Or VA minus the voltage difference, right? Because we don't know the exact voltage that's on that wire, but we do know the voltage difference across this entire series circuit, right? Which is going to be this wire, right? This whole entire wire is a series circuit. And what is the voltage difference across this whole entire wire? The voltage difference across this whole entire wire is going to be the voltage difference of the battery, which is 20. So that's how we're going to write our equation. Now, I know that may have just sounded confusing, but the again, like I said, the more you see it, the more you start to understand. And don't worry, I will bring it up multiple times, so you will have a lot of time to understand this, right? Okay, so let's write out our equation. So we're gonna hit the resistor there, right? So Ohm's law is gonna take effect. So what we're gonna do, since this is a series circuit, we're gonna follow series circuit rules, right? And we're gonna add our two resistors, right? So we're gonna do 5 plus 4, and that's gonna be 9. So what we're gonna do is we're gonna take the voltage difference, right, of VA minus 20, because that's the voltage difference of the battery, right? So we're going to do VA minus 20 divided by 9. And that's going to be our first equation. That is our first equation. VA minus 20 divided by 9. Because, 9 is the total resistance, right? And VA minus 20 is the voltage difference of, these 2 points, right? Again, like I said, I know that sounds confusing, but you're just going to have to roll with me for now, right? You're going to have to roll with me for now. So let me make this a lot more neat. All right, here we go. All right, so we've completed this. This wire is complete. Now let's move to the next wire. Okay, so we're going to do this, right? So hold on. I want to make sure I label those points too, just to have some reference. So where's my thing? Minus. And this is going to be positive. me see how much time I have on this video. All right, 10 minutes. Should be able to finish. I don't know. We'll see. So I'm going to do minus. Here we go. I'm going to do positive. What we're doing. Because we know VA is going to be the high potential. Theoretically. So we're going to write our equation. VA minus 0. Because that's ground, right? VA minus 0, right? Divided by 3, right? We're going to add that, right? So we completed this. We completed this right here. Okay? Now, we're going to go from ground to the positive, right? So we went from... So we're going, right now we're going from high potential, right? Because that's what the positive is, to low potential, right? We just went from high to low, right? So if we're going from high to low, right, that must mean, right, that that's a voltage drop, because we're going from positive to negative. If we're going positive and negative, that's a voltage drop, right? So let's write that down. Actually, I want to label this too as well, just so we're not getting confused. Label that 1.0. Here we go. All right. So we're going to label that. So if we're going to, so we're going to do VA, which is the voltage difference across that resistor, minus, right? Minus negative 12, right? Because we just got a voltage drop there. So when we went through this 20 volt, right? We got a voltage lift, right? So we would do, because we know negative to positive is a voltage lift, right? And all this equation is saying just the voltage difference, right? So we know this is a positive 20, right? Because the only reason why it's subtraction is because the equation calls for attraction, right? Subtraction, right? So when we do, so we're going to call for subtraction here again. We're going to do high potential minus low potential. And the low potential here is negative, right? The low potential here is negative. So we're going to do VA minus 12 volts, right? VA minus 12 volts, right? And we're going to divide that by 10 ohms, right? We're going to divide that by 10 ohms. And all of that is going to equal to 0. And now we can finally start doing algebra. We're done with the electrical engineering crap, and we can finally do the simple stuff, which is the algebra. So let's do that real quick. Let me move this down here just so we have some room. Okay, let me see my recording. All right, I should be able to solve this. We'll see, though. We'll see if I can, how fast I can go. All right, so we're going to do VA divided by 9, VA divided by 3, and VA divided by 10. Ooh, I actually don't know what can go into all of those. Ah, snap. I'm going to have to, what face it in the recording.